Recording, there we go. Okay. So there will be lesson videos. I just realized I hadn't quite gotten all your channels up. There's also going to be a channel that has our class notes. Okay, and I don't have that up there for you yet, but those are going to be, I've got all of this like on the computer and then we write on it. So if you miss something, the written on copy will be in the class notes. Okay, I'll show you on my other team. Okay, because I did manage to get it up for my grade regular 11s. So for example, here is their class notes. And if we click on that, it gives you a link to what we did today, or all the days really. And this does take a moment to load. Okay, and it doesn't look like this, just give it a minute. Come on, you can do it. There we go, okay? So this is their workbook, all right? And if you just go on this first page, that's only the cover page, you won't see anything much. You'll be like, well, hey, that's not very useful. There is a little bookshelf icon. Do you see it up at the top left there? If you click on the bookshelf icon, it will give you the whole list of all the things in that section. So if we want that, and what did we do today there? We did SI units and prefixes. I don't know how quick it syncs, so I don't know if it's actually got it there, but let's see. Oh yeah, you see how we've got today's notes? I'm gonna close the bookshelf because I don't wanna see it anymore, okay? And you can see here we wrote things, so you can also access that yourself. I'll get that up there right after school today for your class, okay? Back to our team. There we go. Okay, so class notes will be there, and the last thing, probably you may have seen this already, is in our general tab in the files, you'll see if you want any of the grade 11 stuff that like you sort of did over the summer, but like the first 4 units of grade 11 is essentially what you did over the summer. They are in here, okay? But your unit is the mole. That's what we're starting with. So you can click on there, and you will see here are all the individual worksheets, but here is the whole workbook and the whole answer key. And if you click on it, and it takes a minute to get there, but if we zoom in a little bit, you see how it highlights, right? You can then go and click there and it should take you to the right page. Those were all entered by hand, so if it doesn't take you there, you might have to go searching for the page, but hopefully I did it right, okay? So if you forget your workbook at school, there it is. It's all good. Is good? Okay. How are you guys doing? How was your summer? It was nice? You didn't spend too much time doing chemistry? Okay. All right. Shall we get started on content? Because we got a whole lot to get through. Yeah. Okay, we're recording and we are now here and we want to go to moles. And I am actually going to leave it to Tyler DeWitt to teach you what a mole is tonight. So that's going to be tonight's homework, is what's a mole with Tyler DeWitt. So we are actually going to go to 5.1D, which is on page 13. Because I promised you little reviews, yes, of things that you did over the summer. Now, writing formulas is something you've done in grade 9 and in grade 10. So hopefully this should be easy, yes? You now have a periodic table. Did everyone get a periodic table? Yes? Okay. You have in your periodic table, Two of you got a weird one. I'm sorry, I will find you a good one. I think it's you two guys back there, okay? You got a weird one. You didn't get one either. Okay, so I'm gonna find you a good one. And actually, you know what I'll do? Here, you guys get a grade 12 one for today, and then I'll get you one that's more appropriate for grade 11. Oh, you all didn't get one. Oh, did I not have one? Okay. Thank you. So, what you're going to do is you're going to practice and see how quickly you can write those formulas and then count up the number of atoms. Okay? So this is like, go quickly. And if you get to something and you're like, I don't remember how to write the formula for an acid, you're going to put up your hand and say, I need a review of how to do the formula for an acid. Okay? And then I'll do it for the whole class. That way we'll find out. Don't look at the list of acids for the acid names. See if you can do it with just the front page and the second page. Okay? Yeah, you can use your periodic table, just don't use the list of common acids. That's kind of like too much information. And doing the other okay, so part of the reason that they don't have iron is that you always tell I will for so what will happen is if I do chromium, like for example, yeah, I will come back forward here, going backwards. No, this has to be forward. Oh, I remember. I know, right? Please let me know if you're having any difficulty with the charges. I can come over and give you a quick lesson. Okay. Okay, so acids. Let's do a little on acids here. Gloves. So, going to do a quick little lesson on acids. If you're fine with acids, you do not need to listen. But if you're kind of on acids, You can listen. If you need some paper, there is free blank paper at the back of the room. It says free blank paper. We have 3 types of acids. There's the hydroic acids. There are the ic acids. And there are the us acids. And there are 3 ions that correlate with these. These correlate with the ide ions. The ic acids go with the ate ions, and the us acids go with the ite ions. Okay, so if you come across an acid that says nitric acid, you say, okay, that has the ic, but it does not have the hydro, which means it is based upon the ate ion. So that's going to be nitrate. And does anyone remember the formula for nitrate? Not terribly surprising at this point. It is N. What's attached to it if it's got an 8 ending? O, okay? And nitrate is NO3, and it has a negative charge. But those should be on in your, like, flip the periodic table when they should be in there. Okay, so you can look those up. We won't bother memorizing them at this point, okay? So now we have nitrate, and when it is an acid, that means that whatever your, what do we call a negative ion? A negative ion, yes, is an anion. So that's our anion, negative ion. And hydrogen is the positive ion. What do we call positive ions? They are cations, and if you have trouble remembering that, you can remember that cats have pos. So cations are positive. Okay, so cations are positive. If you have trouble remembering that anions are negative, anion looks like onion, and onions make you cry. And that's negative, or at least sometimes. Although a good cry can be a positive thing too, but we'll say it's negative, okay? So you're going to take your cation and you're going to take your anion. You need to make sure that the charges, what do what? They have to cancel each other out, so we have a positive and a negative. This one's super easy, right? And you just write HNO3. So what it comes down to is remembering which type of acid goes with which type of ion. Do you guys know the mnemonic? Do you guys know what a mnemonic is? A mnemonic is a memory device. Do you know the memory device for the acids? Yeah, okay, so my ride has hydraulics, okay? My ride has, this isn't spelled right, but that's okay, it works with this, hydraulics. And then we have ate. I ate something icky. So we have the ide ions are the hydroic acids. So if I said to hydrochloric acid, we have the hydro and the ic. And that tells me that I'm going to use the Why is it not? Oh, it's not responding to me. It's like having a little hissy fit here. Hello. Okay, sorry, I'm gonna have to close this and open it again because it's not being happy. Oh, it's really not happy. I love technology. Carry on, we'll come back to this when it stops being, you know, fussy. Oh, I think we're back. Okay. So if you had hydrochloric acid, you take that root, that chlor part, and you put it together with the ide ending. So that's going to be your chloride ion, so that's Cl minus. And then of course it's an acid, so it goes with H plus, and then you put those together. Okay, so that's, first one is my ride has hydraulics. Second one is I ate something icky. So if you have just ick without the hydro, so like sulfuric acid, then you go and you say, I've got ick, but no hydro. So that's going to be the 8 ion. So I look at sulfur, and that would not just be sulfur, it would be sulfate, which is SO4, 2 minus. And you can look those up, of course. You would put that together with your hydrogen. Do these charges equal out? Do they cancel each other out? No. So you would need to then have how many hydrogens? 2. So it would be H2SO4. And then finally, if you have an us acid, that one is my Sprite, is delicious, which is good because we ate something icky, now we get something delicious. So if you have an acid that ends in us, like phosphorus, acid, then you say, oh, I have an us. Well, there's no hydro us, there's just the us, and so that's going to be the ite ion. So you go and you say, I've got the phosphor part, so that's going to be phos, and you're going to put the ending ite on it. So that's going to be phosphite. And phosphite, you can look up, that is, what element is it based on? Phosphorus, so that is P. You can look up the ion phosphite, it is PO3, 3 minus. And because it's an acid, that means it's going to get together with H plus. Can I write it like this? Would it be okay to write it like this? Is that an okay way to write a formula? No. The cation always goes first, okay? Yes. So the positive one is always first, the negative one is always last. So it always, yeah, so it's always positive, then negative. Always the cation, then the anion. And so for this one, it would be H3PO3. Okay? Just had a good point brought up on our organic acids. Do you guys know what organic compounds are based on? Yeah, they're based on hydrocarbons. So carbon with some hydrogens and possibly some other stuff. So organic acids, organic means carbon plus hydrogen plus maybe some other things, okay? Your organic acids, they have a special group. So when we're looking at the structure of the molecule, we have a carbon with a, what does it mean if I draw two lines there? Do you guys know? That is a double bond, okay? That's a double bond. And don't worry if you're like, oh my God, this is going really fast. I don't know what a double bond is. And like, we'll have a whole section on bonding, okay? Oh my God, I don't know what organic chemistry is. Oh my God, oh my God. Don't worry, we'll have a whole section on organic chemistry, okay? But this is what, just like a little preview of what happens, which explains why organic acids are written in a strange and different form, okay? This group here, a carbon, which has a double bond to an oxygen, and then a single bond to another oxygen, and then a hydrogen on the end. This is an organic acid. Specifically, these are called carboxylic acids. Do you need to know that term for this unit? No. Okay, so don't be like, oh my God, what's carboxylic acid? Do I need to draw this? No, you don't. Okay? But it explains why when we write an organic acid, we always have the ending of the formula is COOH, because it reflects the actual structure of the molecule. We have a C bonded to an O, bonded to another O, and bonded to an H. At this point, all you need to do is recognize that you have the COOH is an acid group. Yes? Yes, because when we have acetate, so here's acetate, it would be CH3. We have our three H's. and then C with a double bond O, and then an O, and there's the negative charge. Okay, it goes on that single bonded oxygen. Then when we have acetic acid, instead of just having that negative sign floating around by itself, that's where that H plus attaches, and that makes it neutral. Okay, yeah, and we just write it because that's the way the structure is. Like I said, you don't need to know the word carboxylic acid. You don't need to be able to draw that structure at this point. You just need to be comfortable with the fact that this is how they're written, and this is the H plus right there. Okay? You may not have learned that over the summer. I couldn't remember. Yeah, I can't remember whether it was part of it or not. Yeah. Hi. I'm just gonna talk about hydrates. Should we talk hydrates? Yes. Okay. And if you guys decide that you would like a worksheet on hydrates, I can provide you with one, just let me know, okay? Or on acids, like specifically acid naming, hydrate naming, if you're like, I would like some extra practice, I can make those for you, okay? So just request them. Request worksheets on acid, hydrate, if you want them. Okay, hydrates. Do you guys know how ionic compounds, like the structure of an ionic compound? First of all, what's an ionic compound? What makes a compound ionic? Yes. Yeah, we have a metal and we have a non-metal. Okay, now that's That's the case most of the time. What kind of, because they're ionic, what does that imply that they involve? Ions, right? What kind of ion does the metal? It's positive. So this is our positive ion. What do we call that? That's our cation. Our cation. Okay, our cation. And our nonmetal will be the negative ion. Okay, and that is the onion or the anion. Okay. Now, what happens is when you have this positive and negative ion, do you know what structure that forms? No. Okay. I'm going to draw it in 2 dimensions, all right, and then I'm going to bring out a model to show it to you in 3 dimensions. If we have a positive ion, where do you think the negative ion wants to go? Right next to it. Why? Positive and negative do what to each other? They attract. Okay, so if I have a positive ion, it wants to be beside the negative ion. There's a reason I've made it bigger. Don't worry about that right now. Just go with it. Okay. Where would my next positive ion go? Right beside the negative. And how about my next negative? Right beside the positive. So now we've done this in 1 dimension. Yes. If we want to do it in 2 dimensions, what's going to happen in my first column? What's going to go next? A negative. And I'm just going to start filling these in like this. Yes. And I can put my positives in here. So it's basically alternating positive, negative, positive, negative. And then I would have a positive here and a negative here. Okay, so now we have this lovely structure in 2 dimensions. I will not try to draw this in 3 dimensions. I'm going to go get my model. Here's our lovely model. You see how they are green and gray. Okay, so we have gray, then green, then gray, then green, then gray, then green. So in addition to alternating in a sideways and up and down way, it also does it in a front and back way. Yes, so we have a 3-dimensional alternating positive, negative ion. This is called a crystal lattice. Okay, a crystal lattice. Specifically, this is an ionic crystal lattice. You're like, I thought we were talking about hydrates, Ms. Spence. Why are we talking about crystal lattices? Well, what does the word hydrate make you think of? Hydrogen, but even more than hydrogen, if you want to go and hydrate yourself, what will you do? You're going to drink some water. So a hydrate has to do with water. Okay, so hydrates have water. Okay? Within this crystal structure, wrong drawer, we're going to have, now do you guys know the shape of a water molecule? Do you know what it looks like? Or a right side up Mickey Mouse, depending on how it's, whichever way you want, because they tumble around, yes? Okay, so we have water, which is like a little Mickey Mouse. We have the oxygen, and we have 2 hydrogens. Okay, so there's our little Mickey Mouse water. And I think this is not a bad representation of that because we've got 2 things at the top, yes? And then we have 1 thing kind of in the middle. So these are going to represent our water molecules. In our crystal lattice, what do you notice about the lattice? There's space in here, yes? And water is a very, very, very small molecule. And it actually has charged ends, positive and negative itself. We'll talk more about that later. So what happens is in some crystal lattices, within the structure, you actually get water molecules embedded inside, okay? So inside the crystal lattice, you have these water molecules. These bonds here, positive to negative, what kind of a bond is that called? Do you know? It's easy. It is an ionic bond, okay? So right here, okay, in between there, we have an ionic bond, okay? So there's our ionic bond right in here, all right? This guy is bound in here, but not by an ionic bond. Ionic bonds are between ions. And ionic bonds are very, do we know if they're strong or weak? They're very strong, okay? Ionic bonds are strong. I'm going to redraw our crystal lattice with some space in it. So these are strong ionic bonds. And then embedded in that space, we have, who's embedded in the spaces? Water. This is a hydrated crystal lattice. In other words, it is a hydrate. You guys know what the meaning of IE is? IE stands for id est, which is Latin, which means that is. Okay, so if I ever say IE, that means in other words, that is. Okay, so because you'll see me use it a lot. So IE, it is a hydrate. So a hydrated crystal lattice is what we call a hydrate. All right, so the waters are held in there by weak forces, not strong ionic bonds. These are molecules, okay, these are not ions. They don't have an overall charge. They're held in there by weak forces. So we're actually going to do a lab a little bit later on where we have a crystal that has the water embedded in it, and we're going to heat it. What happens when we heat things? The molecules move faster, okay? So everything moves faster. And what happens to bonds when the molecules start moving faster? They're going to start getting weakened because the molecules are trying to escape. Now, we have strong bonds between the ions, but weak bonds holding the waters in. What happens to the weak bonds as it gets hotter and hotter? They break, and the water boils off, okay? And we are left with what we call the anhydrous salt. The anhydrous salt, an meaning without, hydrous meaning hydrate, okay? So when you heat it, the water actually comes out and you're left with the salt by itself. Now, if you drip water back in, then, All right, it actually will rehydrate. Okay, and we're going to do that. We're going to do some math around that and some stuff like that. But yeah, so in here, the waters are bound within the ionic, what's the term for the entire structure? The crystal lattice, yes. So the waters are bound within the ionic crystal lattice by weak forces. Does anyone who had me for Science 9 know what those forces are called? Those weak forces that hold molecules together. Intermolecular forces, or IMFs. And if again you're like, oh my God, do I need to know IMFs for this? No, you don't need to know IMFs for this unit. They will take place in the bonding unit. But we are going to do the lab with the hydrates, so it is nice to know that those bonds are weak. So when you heat a hydrate, those weak intermolecular forces break, and the strong ionic bonds, do they break? No, you would need to heat it to much higher temperatures, okay, like 1,000 degrees or something like that, okay? So this stays intact, the water comes out. So upon heating, the weak what things break? Intermolecular forces, intermolecular forces break, but the strong ionic bonds stay intact. And therefore the water is driven off of the hydrate. Yes. Water is the most common. I mean, it is really one of the very smallest little molecules that is also, it has a positive end and a negative end, so we call that a polar molecule. There are others that are likewise small. I assume there are other things that can do that, but it's just not as common. Water is so, ubiquitous, it's everywhere. Yeah, I don't know if there's any other really common ones. Okay, yeah. That's a really good question, and I honestly don't know. You might be able to. Yeah, I assume somebody's done some experiments with that along the way. Yeah. So the water boils out of the, what is the word we use when the water's in there? It's hydrated, so it boils out of the hydrated crystal lattice, leaving us with the, and here's a new word for you, and again, you don't need to know this for this unit, but it is part of the lab, so I'm mentioning it, okay? with the anhydrous, I cannot spell. I still can't spell. There's a D before the R. I want to make them one letter. An means without. Hydrous is water. Okay, so that leaves us with the without water salt. Now, what's a salt? Yes, it's just an ionic compound. Okay, a salt is just an ionic. Why am I putting it in quotes? It's not in quotes. It's not a salt. It's a salt. It's a salt. Maybe I'll highlight it. A salt. So there's table salt, right, which is sodium chloride, but any other potassium nitrate, whatever, those are also all salts. Okay. So this is an ionic compound. You can rehydrate it by adding water. So when it comes down to, now we're finally coming back to the whole point behind this, how do I write the formula for copper 2 sulfate pentahydrate, right? That was what this all was leading to. So we look at it and we say, what is the charge of copper? 2. That's why there's no charges on your periodic table this year. The ones in the middle will always give you the charge. Do we know our charges of the rest of the periodic table? Yes. If you have questions about it, do ask. Okay. So we have copper 2 plus. We have sulfate 2 minus. So we have Cu SO4. Are we happy with what I've written? No, no brackets, because there's only one sulfate, okay? So CuSO4, I've left too much space between those. I'm going to bring them closer together. CuSO4, this little dot does not mean times, it means loosely bound. And how many waters? Penta means 5, therefore there are 5 H2Os. So that's how we write the formula for that. So what that means is for every 1 copper sulfate, there are 5 waters in there. So instead of maybe just having 1 in there, it'd be like 1, 2, 3, 4, something like that. Okay. So those are our hydrates. What was the other one? Mercury. Mercury is just a bizarre little funny thing, okay? What do you guys know about, that's weird about Mercury in its elemental state? Yes? It is liquid at room temperature, okay? I think the only one that even comes close is gallium, which if you hold it in your hand, it will melt because it's got a melting point of about, I don't know, 36 or something like that, and we're at a body temperature of 38. But my husband got some gallium, I put it in my hand, and it made a big black mess on my hand. So I don't advise doing that. Put it in a plastic bag first and then hold it, okay? All right. But mercury in its ion state, mercury is Hg. Okay. First of all, it's got a funny symbol. It's like from hydrogyrum, I think is what it's short for. It's the Latin for mercury. And when we have mercury 2, that's a nice easy one. Mercury 2 is just normal. What would the charge of mercury 2 be? 2 plus. And so if we had a mercury 2 plus ion, it would look like a circle with a mercury in it, and it would have a 2 plus charge. Yay, that one's nice. Mercury 1 is different. It is actually Hg2 2 plus. Okay, weird. So how many mercury atoms are involved in this? or ions. How many mercury particles? 2, right? There's 2 of them. Okay, so we're going to, if we actually looked at the structure of this thing, have 2 mercuries. The total charge is +2. So what's the charge of each mercury? +1. So that's why it is mercury 1, because the charge of each mercury is 1. Yes, just mercury, only mercury, because mercury is just a weird little guy. He does his own thing, okay? What kind of an ion would we call this, where I've got those 2 particles bonded together? Oh, that could be, they could be bonded covalently, but I was looking for another term where we have an ion with more than 1 particle in it. That is a polyatomic ion. So mercury is a polyatomic ion. Okay? There is also a problem with the answer key. I think it was number, what number was it? 14 or something. Anyway, there's a 2 missing somewhere in the answer key. You can find it and let me know. I'm going to find it and correct it. Your homework, you're going to have Tyler teach you what a mole is. So 5.1a. And 5.1b. Okay, 5.1a and 5.1b, there's 2 videos to watch, and just fill in the notes with Tyler. That way you'll be all ready to start on moles next day. Yes? If you are ever finding that this pace of this class is just too crazy, tell me, and I can like go back and do other things. Do you know what I mean? Like we can move it backwards a little bit, okay? But we're going to do lots of review as we go through this first unit. Lots and lots of review. I will post your homework on our team. Oh, ladies and gentlemen, one thing. Anybody want the extra acid practice? What if it's not mandatory? Okay, and how about hydrates? Just everybody, I should make hydrates and acids I'll make it for everybody, it's not mandatory. Okay, I'll just make it for you so you have it. Okay, cool. You might as well get them, yeah. I'll get them for you tomorrow, yeah.
Miss Vance, do you need to see a receipt for the workbook? Because I check in math class.
Oh, okay.
My mom paid it, so.
Okay, you know what? That's actually a really good idea. I should probably do that too. I never thought of it. Yeah. So yeah, why don't we do that? I've only been doing workbooks as long as math, so Stephanie, workbook, yay, thank you.
All right.
Awesome. Hi. Pardon me?
Everything you just did will be on tape.
Yes. So what I'm going to do is right now I'm going to go on here and put the link to those class notes. So when you go into the class notes, I'll put today's date on this one, and yeah, yeah. Thank you guys. Hi.
All of these notes are on tape.
They all will be on Teams. I just have to post them up. I haven't got our class notebook, but I'm going to do that right now, so it should be up there, yeah. And let me know if you have any problems finding it, okay? Yeah. You're welcome. Thank you. See you later.